Welcome everyone. Today we have a Nissan Navara with the 3-liter turbo diesel. Now this one's 2005 Nissan Navara D22 and it's got a ZD30 engine in it. This is not a common rail diesel. This is old school rotary pump style diesel pump in it, and the customer's complaint is the car does not start. I'll just show you quickly. Trying to crank it and see if the car starts. Yeah, it cranks but it does not start. Now when I'm making this video, I just gotta warn you guys, I do not know 100% what is wrong with this engine. It does not start, it cranks. This is just a video on showing how you can check the fuel pump module. The fuel pump sits right here where my finger is pointing, in that area. The fuel pump module is very common on this engine. Sometimes when you're diagnosing cars, if you don't know what's wrong, you at least got to know what is right. We know what's working, and then you can sort of figure it out what is not working then. So that's all I'm doing on this engine. I spend a lot of time on this car trying to figure out what's wrong with it, and I think it needs a new fuel injection pump. But before you tell the customer it needs a new injection pump, we're gonna have to cover all the possibilities. That's all I'm gonna show you. The fault code in this engine is, I think, coming up with spill valve something. Now I'm not going to show you the scan tool fault codes and all that, because my scan tool for some reason does not want to talk to this car. It does talk every now and then, like you have to wait like 5-10 minutes and finally it will talk and you won't have a live data. But I tried my other friend's G-scan he uses, and it does talk to the car. So that's the fault code, it's in there. I'm not going to show you that part. All I'm going to focus today on how you can check all the wirings going into the fuel injection pump. And we're going to do a lot of testing on this connector here. So basically the engine harness comes here, there's a plug there, blue plug there, and there's another intermediate plug that goes from there all the way to the fuel injection pump. I think it needs a fuel injection pump module. Now I am gonna recommend customer to take it to the diesel specialist and get them to replace or rebuild that fuel injection pump. Now where we are located here in Australia, it is really expensive to change this pump. It's gonna be at least $5,000 job, and looking at the car and the year and model of it, I don't really know. Personally, I won't spend any money on this ute, but it's up to the customer. Now I don't have any good information on what I'm seeing, what I need to see on the fuel injection wiring, but I'm just gonna show you what I think it is. And like I said, I'm not gonna take 100% credit on this is exactly what you need to see, but in my understanding, what I think it is, I'm just sharing it to you guys. If anyone ever come across the same problem on a D22 Nissan Navara. So let's begin the test. So first of all, you gotta make your basics checks right. Obviously a fuel pump to work, you're gonna need a constant fuel supply. So I would start with the fuel filter here and the fuel pump, hand pump. Make sure this is hard and tight. So now one will be coming from the tank, one will be going towards the fuel pump. So if you go to the other side, the fuel line runs down here this way and then goes down to the fuel pump, which is pretty hard to see on this engine. So basically you can see two rubber hoses going in there. I'll just put my torch there. So this one rubber hose is your supply. So make sure you're getting plenty of fuel here. Low pressure fuel supply right there. Now this little one here is your return line from the pump. So you also have to make sure the fuel is going in and also coming out. So what you can simply do is just take this hose off and crank the engine and see if there's fuel coming out. And that way we know there is plenty of fuel and it's not the air issue, low fuel pressure supply issue as well. So while I'm here, I'll just quickly show you the harness, which is down in that location right. That's a pump there, and behind the pump, right behind the pump, there's your it's hard to see, but yeah, it's really difficult to see, but where this harness runs down, it goes and meets with the black big connector at the bottom. Yeah, you can take them off. It's not that difficult, and just gotta make sure you check all the signals and everything we check on this harness right down at the connector as well, because I've heard those connectors also are a common problem on this type of engine. Now yeah, so that's where we were checking on that blue plug, and that's your crank angle sensor plug right there. First thing we want to do is quickly check the crank angle sensor. I'm just going to show you what signals we're looking at and which wires what. So I'll zoom it in what I'm working at. So that plug there, right there, that's your crank angle sensor plug. Now this side of the sensor wiring goes down in front of the engine behind the crankshaft. You'll see red, white and a black wire on that side, but we're not interested on that. That's just the sensor harness. This is the engine harness on this side coming in. We got gray, brown and a yellow wire right there. A yellow one at the top is your sensor signal, crank angle signal. The middle one is the brown, is your earth, and the last one is your gray looking color. It's your sealed ground. So it's a sealed circuit. Only the main thing we focus on is this two wire. So what you need to see when you're checking is you want to see a ground there. You can simply use a test light to the positive, battery positive, and then you can test that brown wire in the middle, and as such, and my test light is lighting up. The middle one is a ground. The third one, the gray one, you don't need to really check it, but it's just a sealed for the noise, so we check it anyway. Same thing, test light connected to battery positive, and that one lights up, so we know there's two grounds in there intact. Now the third one is a signal, crankshaft signal. Now what you need to see here is AC sine wave. So this is induction type crank angle sensor. It does not need external power source to power it up. basically you can disconnect this harness and check it just with the sensor without plugging the engine harness, and you still see the same signal because they make their own AC voltage. So we're just gonna quickly verify if our crank sensor is making signal. So we just plug it in to our scope just on that yellow wire, and you can always put second channel to the sensor ground right next to it on that brown wire, but in this case it's not very necessary. We're just gonna focus on that yellow wire and just a battery ground. Alright, here's my screen Pico scope. We're gonna see what signals we got on that yellow wire. I quickly put this up on the screen and I'll show you what we're looking at on this wiring diagram as well. So basically we're looking at that sensor right there. I'll just zoom it in a little bit more, and so basically that's the sensor we're looking at. Gives you a picture there, but we're not interested. So we got a yellow wire, you got a brown and a gray wire, but in the diagram it's showing as a black, but it doesn't really matter. It's just a sealed circuit, that one. So yellow one is a signal and the black one, brown one is the computer ground. So they both go to the computer on pin 44 and 47. It's an inductive type crank angle sensor. We'll just see what signal we're looking at here. I'll quickly crank the engine for you. So basically we're looking at a signal like that. As such, it's a sine wave AC signal. And we know the crank sensor is working just fine. Now we need to verify if this signal is getting to the computer itself or not, but in this case we don't really need to worry about it, and I will show you why we don't need to at the end of the of this video. So we are happy with the crank angle signal. Now, so if you look right in there, I'll zoom it back in. You got that yellow blue plug there. So that's the connector for the fuel pump module. Now the computer harness is on this side, blue plug, and then it goes down. There's an intermediate plug between there and the pump as well. Just a short plug. It's a short plug from there to the pump module. But we're gonna do all the testing up here because it's easy. It's a little bit difficult to get to the bottom where that connects to the fuel pump. So basically we can do this test with it disconnected as well, or you can check it with it connected. It doesn't really matter for what we're doing here today. If you look right here closely, you'll see 6 wires going into that plug. So on this side here you'll see red, black. Those red and black are the main power supply to the pump, so they're thick wires, so you won't miss it. So red is the power, 12 volt, and the black next to it is your ground. So we quickly verify if there's power and ground present there or not. The back probe on the black wire there, and we're simply going to use a test light and we're going to verify our earth. So that earth is working. I got the ignition on too. Now onto the next one is a red wire, and that's where you need to see the power. So the test light to the battery negative, and we're gonna look for power, and it powers up. Test light is nice and bright. We know there is power present there all the time. Now if we move on to the other side of the wires here, you'll see a little 1, 2, 3, 4 other small wires. Now this 2 wire here, one's a purple, I'm pretty sure that's it, and one's a green with a yellow wire, and these 2 are the communication CAN bus wire. So one's CAN high and one's CAN low. We can quickly check on the screen, see which ones are high and which one is low, just for so you guys know. So basically we're looking at this one here. That's that's not it. We're looking at this one here. That's your fuel pump control module, and you'll see, I'll just zoom that a bit more, and you'll see we got green with the yellow, that's a CAN low, and violet is a purple, or violet is a CAN high. So, and the red one is here, power. It comes directly from the fuse. We know there's power there, and we know there's earth on that black wire as well. We'll first check the CAN low and CAN high, and then I will talk about the other 2 wire, which is your blue with the silver and blue with the red. So we're quickly gonna check the CAN low signal here. In order to do that, I'm gonna have to change this setting here to DC, and we go plus minus 10 volt. We might throw in a channel A as well, plus minus 10 volt DC, and we probably gonna go maybe a 50 microsecond, and just close that. Okay, we just set up a trigger here on repeat. Maybe we just drag that up here somewhere, and alright, so we just use the blue channel for CAN low, which is your green wire. So blue channel on the CAN low, which is your green and a yellow wire, and we'll use the red channel on the purple wire there, violet wire, which is going to be your CAN high. Now if you look up on the screen there, you'll see all our CAN bus waveform. The blue one is a CAN low, so which is going from 1 to 2.5 volt roughly, and the red channel is your CAN high. It's going from almost 2.5 to 4 volt signal. We can just change the time voltage level here, might get a better picture. Let's just pull that down a bit. So this is your CAN bus CAN line. I'll pause it, you can sort of zoom in and have a look if you want to look at the details. That's what it should look like on our CAN high and CAN low, and we know the CAN high and CAN low are working. We can try cranking it while we're watching the crank low and high signal. I'm gonna just quickly crank it. think our blue channels come off. I'll quickly fix that. Crank again. Now we're cranking the whole time. You see our CAN bus network is not interrupted. It's not bad. They stayed on their voltage level. Now if you ask me, I don't know what I'm looking for. But to me, when I look at this, voltage level are good. They don't look very, you know, dirty. CAN bus is working just fine in my opinion. Now you can do the same test while it's connected. It might change a little bit on the pattern, but it's not gonna little bit on the pattern. But what you need to see here is if that signals is dirty while you doing this, that means we may have a problem there. So on the screen you can see I got a on the screen you see everything's looking pretty good. It's pretty fast time based. We can slow down the time, you can see a bit more of a picture, but you can see the voltage levels are still good and I don't see any interruption. While we can do a cranking, the same thing. And I don't see any interruption. CAN bus is working just fine if you ask me, with or without it disconnected. Sometimes if the pump module has a problem, in this case the fuel pump module, it can disturb the CAN bus line and it can give you a no start and all kind of other problems. But in this case I'm happy with the result. I'll just disconnect that again. Now the other two cable here is your blue with the red and the blue with the white. Blue with the white or silver. Now this we'll just quickly get a signal of that and then I will talk about it bit more on the screen. Now for this one we need to go plus minus 20 volts and we'll just bring this up. And we'll just set that 0, that's good. Now I'm just going to quickly slow the time base to maybe 1 second, and I'm going to crank the engine. Before we do that, I'm just going to quickly turn the key off and on because it's important. I want to show you something there. That's key off. That's key on. And I'll crank it. And key off. All right, if you look up here, what I did is when this is where the key is off the whole time. Just focus on the blue channel, which is your blue with the silver wire. Basically I'll just show you here too. I'm checking this blue with the white or silver that wire is the blue channel, and blue with the red is my red channel, channel B on the scope. So I have the key off, both sitting at 0 volt. Key off the whole time, then I turn the key on and it jumped up to almost 12 volts. The battery is a bit weak, let's say 12 volt for a brief moment, and then we went down to 0, and then we went up to 12 volts again while still have the key on. Next screen, my key is still on, and the red channel is staying 0 the whole time, and as soon as I start cranking it, this is still staying at 12 volt, but because we have the cranking starter motor cranking it, so the voltage is going to drop a little bit, but we say it's staying at 12 volt the whole time. And next, go to the next page, and when I turn the key off right here, it went down to 0 volts. So let's go back to the other page and we discuss about this red channel. It was staying at 0 volt the whole time, and when I started cranking it, you can see some sort of signal coming from the ECU. But I think, in my opinion, this is the injector turn on signal. And I'll show you why I think it's injector turn on signal in a minute. Let's just go back to the blue channel, and the blue channel, I think it's some sort of turn on, turn off signal, like a fuel cutoff solenoid or something in that fuel pump computer is telling to turn on, because as soon as I turn the key on, you can see it's sending 12 volt here. It went off briefly and then came back to 12 volt again and stayed at 12 volt until while I'm cranking, and until I turn the key off, it stayed at 12 volt. I think it's some sort of signal to turn on the computer or fuel pump module or something, some kind of turn on signal in my opinion. However, the red channel, I think is computer is sending signal for the injector to fire the injectors, in my opinion. What I'm going to show you next one might make a bit more sense to you. So what we're going to, so I'm still staying on the same wire, which is your the red channel, channel B, blue with the red wire, and I'm just gonna take this off the channel A, because we know that's just a turn on and off signal of some kind. If someone knows more than what I know, they can comment and let me know. But in my understanding, that's all the information I have, and that's all I gathered. I think it's some kind of turn on and off signal. Now I'm going to take the channel A, and I'm going to put it on the crank angle sensor. So just the yellow wire on the crank sensor like we discussed earlier. We're going to get a signal from there, and also I'm going to use my amp clamp on the battery cable. It's a 2000 amps clamp. We're going to see the compression, relative compression as well at the same time. Now up on the screen here, we're going to just set up our measurements. So for the A channel, which is crank angle sensor, I'm going to go plus minus 5 volts, and it's AC signal. So we're going to go AC, and on channel B, we haven't changed the channel B, can stay there, and channel C, we're going to use a 2000 amps clamp right here, and then we're going to put it to minus 200 to 1000 amps, and then we're gonna run this. So I'm gonna quickly crank the engine. there. I'll just pause this real quick. Now we go back to see what we got. So basically right here I'm started cranking it. We just go to the next bit. The engine sound a bit funny to me too, but not sure. For now I'm just gonna focus here. Alright, on the screen I'm seeing the crank angle sensor, the blue channel, this one, and this down here is my blue with the red trace, and this cable coming from the computer pin 53 going towards the fuel pump module, and up here is our relative compression test using our amp clamp. Now I'm just going to use the cursors here and put it on the TDC, almost to the TDC on the compression there, and we go 1, 2, 3, 4. So that should be our 4 cylinders. No, sorry, 1, 2, 3, 4. That should be our 4 cylinders, roughly there. So if you see here what I mean, this is a crank angle sensor, and these signals coming from the ECU lines up exactly every time when the crank sensor is producing signal right here. If you follow that, every time it lands on the same mark. And up here, if you see the compression of the engine, I'll just try to make that a little bit better so you can see what's happening. So anyway, up on the compression we got highs and the lows. So the high is your top dead center, 1, 2, 3, 4. It's almost it's about 4 cylinder. Now it's not always going to be exactly on the TDC, but it sort of gives you a rough idea somewhere around TDC. So see how every time it's on TDC we got the signal from the ECU and the crank sensor at the same time, but every second one. So this one TDC, second one doesn't have a TDC, but they also have the same signal. When another cylinder is on TDC, we have the same signal here. Same every second, and they all land exactly on the same line, same time. So that makes me believe that if you see this red pattern on the fuel pump harness there when you're testing, you know your crank angle sensors are good, because that's why computer knows when to turn the injection pump on. If I'm not mistaken, this is some sort of turn on for injectors, and every second crank signal there's a TDC on each cylinder. So I think I'm seeing all the signals here that what it needs to be here. We saw the CAN bus is good, we saw the powers and earth for the pump is good, and we also saw the turn on signals, which I think it is good, so I don't see anything wrong. So that's why I think this thing has a fuel pump module issue. Now what I quickly want to do now is I want to plug this in and I want to see if we still have the same signal. That's with the connector plugged into the fuel pump module. I'll just change that to normal module. I'll just zoom that in right there, just click through that. Now that's with the connector plugged in, and we're still seeing the same pattern. We got at the top relative compression and the crank angle sensor, the blue channel, and at the bottom red is some kind of turn on signal for the injection pump coming from the ECU, and they all line up exactly right here. If you just move across, like every second signal lands on the TDC compression, so that makes me believe everything is fine. All the signals going to the fuel pump module is fine, and this thing's gonna need a injection pump. Now before you condemn injection pump, like I said, there is this wiring harness goes below this. There's like a small harness from here to the pump module. Obviously take that plug and check it there as well. Sometimes this this harness can also have a problem, which I've already done it. I have taken it from there and I'm getting all the same signals like I have up here. Now next thing what I want to do is I want to disconnect the crank angle sensor and see if I'm still getting that turn on signal on channel B from the ECU going to the pump here. Okay, you're not gonna see a crank angle sensor signal now, but let's see if I will see everything else. Cranking the engine. Now up on the screen you can see the blue channel's got nothing on it because obviously we disconnected the crank angle sensor. Now we got our compression, but on the red channel here we also got nothing. So obviously engine computer needs crank angle sensor to send this signal to the fuel injection pump. That's what I believe, and now we're not seeing that because we got the crank angle sensor disconnected. So that's why you don't really need to check the crank angle signal on this engine, as long as you check that red signal, red channel signal at the harness at the pump, which you know the crank angle sensor is or isn't working. So this is just my attempt to sort of teach you guys how you can eliminate harness or ECU fault on a diesel Navara D22 before you condemn a fuel pump. That's my whole plan for this video was. Hope you guys learned something. I don't know how the video is gonna come out, but I'll try my best on the editing as well for you guys.